Are you sitting comfortably? Good. Then we'll begin.
Let's go to another application. For all this application, maybe, okay, so let's, you know what? Let's go to an application that relates to a database for our instrument. For the by the way, if you didn't do it yet, if you are not yet aware, if you go to ofsa.ngit.edu, yes. So this is the website of the instrument we are mainly working with, and actually there are more than one instrument here, and we are working on an expansion of the array. So this instrument is not yet producing public data, but there is a section which is says OFSA legacy, and I guess if you go to OFSA legacy data, you can look for some events, for example, 2001 events, and if you go here, you can click any event that was observed by this instrument, and you can look at different physical characteristics. So you can go to this website and try to get used to see how a radio burst looks like. So what you have here is a time, and this is a frequency, and you see that it's not only what you saw here is a flux, but a given frequency, similar with the ghost flux that you saw in X-ray, but this is something that we call broadband recording, in which you have many frequencies, and when you look at frequency versus time, you can see a plot like this, which is called dynamic spectrum. Now, how these spectra were obtained using an application that I developed, which is called for the OFSA Explorer. Yep. And this OFSA Explorer, so you just type OFSA Explorer, or maybe let's do it the other way. So to give you a hint, you can just type OFSA, and you are given with some option here. This is something called OFSA toolbars. Actually, it's a set of applications that you can use to look at OFSA data, and one of them is OFSA Explorer. So if you click OFSA Explorer, you'll be asked to select a file, and I will put some data. Now you don't have these data files available, so you cannot play, but after this session, I will create in the lecture folder a subfolder with data that you can play and download on your computer and play with it. So right now I try to select some data, which I don't even know if I can. I used to have something available. Gregory, do you have any idea where we can have a file interesting?
Yeah, you may have something either in working or in OFSA data or.
Yeah, so actually there is something here. There is something here. I'm pretty sure that this is let's try this one. If not, I will change. Oh, okay. So I found one. So this is basically the dynamic spectrum, which is similar with one of this one, yes. And this is an event that happened on June 30th, 2014. Is that okay? And you can explore. You say this is dynamic spectrum. When you move the mouse, you can see how the light curve look at every frequency which goes in this direction. Yeah, so this is light curve. We call it light curve. So it shows you the flux versus time, a different frequency. So this is one frequency, this is not. You can zoom in and you can see, or you can zoom out by using the mouse. Yeah? And for each such position, you can also see something that is called spectrum, which is spectrum is across frequency. So for any instance of time, you see how the data looks like in vertical direction, which is frequency. And this application gives you the ability to fit the data and extract some meaningful information about this spectrum. Basically, you can see here something called low frequency slope, high frequency slope. So basically, these are parameters that are used to find this curve, which describe the data that is observed by the instrument. And doing so, you can save the data and create something that can be put in the database. And I want to show you, for now, I think I will keep this open, but I go to OPSA toolbar and use, for example, something called plotmed, which I hope I have something med. Actually, I can look for a med file just by searching. Maybe this one, should be the. So this is an application that actually creates a plot based on something saved from OPSA Explorer. Yes. So one way to use it. Another thing you can do with this OPSA toolbar is to launch an application that is called wQuery. And this wQuery actually is a database interface for some events that were pre-processed with OPSA Explorer. And they were saved in something called database, and I can say open database, and I will provide you the database to place with, but I think it should be here. No, it is in Dropbox OPSA Legacy. And this is a database 2001-2002. When you open this database, basically you get a plot like this, which shows you all the events recording by our instrument for 2 years. And this is their frequency, and this is the flux. And basically all of them are listed here. And when you go through each list, which tells you the date and time, you can see how the event evolved in frequency and peak flux for a given, so how they are distributed compared with all the other. And when you click on this button here, you can see details about this event. So it shows you how the event evolved in time. So it's, again, another way to look at the data. So this one, if you display it, you see this is a flare. It shows you that it started here, it's almost ended here. And there are several physical parameters that you can choose from and display. Again. So, again, this is a tool to do research. So what we do with this tool, and maybe you will get to play with it, is to look for such collection of events and select one that you are interested in. For example, I'm interested in this selection for a very strong event in this area. I say query, and automatically I selected here all the events that are here. So now when I go to the full view, you see these are events that somehow they got in this area which I selected by mouse. So this is a way to, and you can display this event and see what are the characteristics of this event and do stuff with this. So this is a way to look at the data in the frequency time domain. But this is not all we do. So these are like light curves and spectra. From those kind of data, we extract physical parameters. But what we really want to do is to make a 3D picture of the what is going on and what produced this kind of emission. So here is where it comes into play 3D modeling. But before doing 3D modeling, we have to do 2D images. And there is a way to do 2D images with OFSA, and I guess I did not include this in the OFSA toolbar. It's not here. But I will do it at some point. But now I can simply, for example, there is another application that is not listed there. It's WU Imager. So you have to remember this. W comes from widget. Imager is like just an acronym for a software that you do images. And when you open this kind of file, this kind of application, you will be given the option to create images from this kind of data. Yes. So basically it tells you how the sun looked like at a given time interval and a given frequency range. Gregory, maybe you can take the presenter, maybe it works from there.